seen the compiler part yesterday, like the compiling of TypeScript
Yeah,
mainly,
yeah,
and then actually giving a shot of creating the which actually creates up the main output of a TS file. Basically, we
yeah.
ran TSC.
PSC
That
and file name, yeah.
exactly. So we just ran my file dot. If it is a TS file, we ran TS file because that was our source file, which actually compiled it. So today, what we'll do, we'll actually keep this on so that when we are actually running through each of the code piece, right? Let it actually continuously convert it to JavaScript. Okay, and let's open up a separate. Let's even close this one. We don't need the file structure now because we already know that we're going to completely work on the my file itself, right? And let's split
Mhm.
a terminal here. So one terminal will be continuously building up, and in this terminal we'll just run node my file. Okay, so that to see the output of it.
Okay.
Okay, so perfect. So now let's start up with the quick things. So um maybe see, it's like there are few concepts which are like a kind of whenever we even start with any programming language, we normally go into basics like what are the data types we have, or what are the um, declarations we normally do. How do we write a class? How do we write a function? How do we call different params, right? How do we actually create an object? How do we create an interface and stuff, right? So in the same way here, right, because we're going to use those across the Angular, so let's understand few pieces which we have. So starting with the data types basically, or the declarations mainly, which we normally call. So yesterday, if you remember, we used var, right, which is a declaration type which qualifies X, and it we assigned something called a string, right? So now what happens, when we actually gave var, which means I can actually give this any type. Like now I just gave a text, so I'll log this. Let's say I'll give something called true, right? So here, if you see in TypeScript, so when you actually mention var with one of the type here, and as soon as you actually try to assign some other value, now this is something which actually gives up in JavaScript itself. Okay, which means whenever we assign any data to it initially, it actually takes up the same data once we actually use the same variable across. We can't actually assign any other data as such. Okay, now this is something
Mhm.
which is a kind of a strict behavior we have in JavaScript.
Mhm.
Okay, so now in the same way, in TypeScript, right, we normally use, most of the times we'll be using two different scope variable declarations called let and constant, and also var. Okay, let's see
Also, what is the third one?
the var, the one which
Where?
we have seen.
Oh,
Yeah, I just gave this directly because it's a simple JavaScript type we had, without any that without any data type restriction. We just gave it to understand how it actually compiles into different things, right? So now let's see how the uh, how we have two more variable declaration patterns we have using let and const. So let, and let's say for example, let I'm taking t as 10 for instance, right? Now we
so
have one
is
more
there
type
any
called
difference between
const.
let and where?
I'm sorry.
Is there any
Yeah,
difference between let?
I'll explain that. I'll
Okay.
explain that. So here, right, the main difference is once you have any variable declared using let, you can't declare the same variable again. So for instance, we have variable x, for instance, right? So let me say variable x is equal to some 8, right? So in JavaScript, what happens once you have, see, I'm actually taking var here because this is something, if I write in a say plain simple JavaScript, right, it will allow me to declare the variable again, basically.
Mhm.
Okay, but in TypeScript, as we use this, let me just completely get into TypeScript mode. So the let is something which, what happens is, in the same scope we won't be able to declare the same variable. For instance, if I try to create something called const or let t again, like giving some other data,
Mm-hmm.
right? So it'll actually force me to say that this is in the current scope, it is already declared, so we can't actually declare the same variable. So this was a problem which we had like long for long period of time in JavaScript, there where we can declare a variable and in the same scope we can redeclare a variable which will get reassigned with the type we are actually mentioning. So that's why as we started learning TypeScript, right, we were talking about one main concept called type based JavaScript, which means in TypeScript the type is enforced here. Okay, so the type is enforced and the strict is also enforced when we are actually writing up any code. So during development type itself, when it actually compiles up, it'll actually show what exactly is going wrong. But in JavaScript world, what happens, you have to find out everything during the runtime. It doesn't actually say, I mean, based on the compiler or editor I'm talking about. Once we actually have the good compiler editor for JavaScript, will actually have the errors shown directly. But in general, in TypeScript, right, because of the editor compatibilities, we can actually get these things directly. So coming back to the let, so once you assign any initialize or declare any variable, you can't redeclare the same variable with the same name. That's one. And second thing is, in general, what happens is whenever you are actually declaring any variable with var or any other type like const or let, right, let have one special feature, like you can actually just declare a variable without a initialized value. I can just say let t, and I can actually say like t is equal to 90. So now when I say t is equal to 90, right, now it will actually take the value of 90 here. One more beauty, let's say I'm going to give something called true, for instance. You can see here. So when I say let t, you can see the if you can see here, right, this will actually compile continuously. You can see found zero errors, which means when I declare a variable called let t, it will take any type of data which I actually mentioned. Okay, and you don't have to actually initialize. For instance, we have const. Now getting back to const, with the declaration itself, we can understand that const is nothing but a constant, which means once you assign a value, you can't change. For instance, if I try to change as 7, right, it will give us a compiler builder saying that, so c is a constant and we are not supposed to assign it back again, so which means we need to have a standard value. Now can I declare a constant without any value? Sorry, here we can't. So
It
constants
won't
is,
allow.
yeah, constants is a type that you have to have a initialization. So whenever you declare a constant, it's same like we have in other programming languages where you can declare a
Yeah.
constant and then, yeah, if it's a constructor installation, you can initialize. Otherwise you have to have a value when you declare a constant, kind of. Okay, so that's a main difference we have with the constant and the let. So similarly, right, where if you we just saw the where also, right, like if I have where I is equal to, let's say I'm just giving a string, right? So here I can't actually declare this with some other type. So for instance, we have just seen I can't actually have I with any other value. So that's a beauty in let. So let, you can actually use any dynamic values you want to assign if you don't assign anything, kind of, right? But it's
Yeah,
not with
understood.
the
Yeah.
with the constant, you can assign only once, and with the where, what it does is whatever value you initialize for the first time, it will actually consider that for the next times too. So now,
Yeah, when I'm reading, I read read only also.
what is it?
Read
Yeah,
only.
that will come. So those are the qualifiers. So
Mm-hmm.
these are the main variable declarations we have, which will be using most of the time. Okay,
Mm-hmm.
we have many pointers. We have read only. There are so many which we have, but most of the times, as I mentioned, that most of the times, whatever we're gonna touch base, I'm gonna discuss here. But yeah, definitely you'll get more and more as we whenever we go into the topics, kind of functions. I'll give you a basic structure, but if you have gone through the handbook, it will have many more actually. The concept of TypeScript itself is like a bunch of things which we can discuss, right? Now, So here even where, if I see here, it's kind of a, where which we takes up and assign. So now if you see the JS file, let me just open the JS file. If you see here, everything is a kind of changed to where. If you see, the variable is t, and then even the constant it is taking, it is converted. But where
Yeah.
exactly is the type restricted? It is restricted in our TS.
Mm-hmm.
Okay. So now let's go back. Let me just close this, because if you see the in a visual in a code editor, if I open up both JS file and TS file, right? So these will actually take as a similar scope, and it actually gives error saying it is already mentioned, but we haven't opened it because this is output file, right? So that's how it actually takes as a module, because every TS, it actually takes everything as a, it should actually take everything as a module, so that everything comes up under a single module scope kind of. Okay, so this is
Mm-hmm.
a quick I mean, across the classes and stuffs we create, it's very important to understand creation of variables and creation of variable under a scope. If you create variable under a scope of a function, whenever garbage collector runs up on a browser compiler, what happens? The scope variables whatever are actually getting disposed will be cleared off. So that's why it's very important to actually take a call on declaring variables, to hold data within that, and then working across different manipulations and stuff. The scope is something which is very important. Okay, and based on this you can actually use whatever is kind of useful. So similarly, right, I mean, let me just take a simple function, not kind of a TypeScript features function. Let's say, let me call something like a sample. This is a simple function I have, right? I can declare a function directly. So now here, if I say let t, for instance, if I say let t as 100, right? Now here I can define. Why? The scope of this let and this let is different, right? So this is a function scoped variable which we declared, and this is something which is a export, the module it is scoped, which we have defined. So the scopes are different. So this is allowed, but declaring the same variable across the same scope is kind of a not allowed stuff. But anyways, constants is something which is completely not allowed across the same module we have. Any question here? Perfect.
No, I'm not.
So yeah, so this is something which we have. Now now we'll see, we were talking about declarations, right? Now as of now we haven't seen anything called data type here, right? So whatever variable data we normally assign, the variable will actually internally holds or typecast to that specific type of variable. For instance, if you see here, I assign string, it automatically says colon string. Can you see that? Where I colon string. Now, so
Yeah.
in the same way, we can even define our own variables. I hope if you have gone through the document, you
Yes,
would have
yes,
seen
they
this.
mentioned that. Yeah.
Exactly. So I can say maybe let some k as,
Colon.
yes, I
Yeah.
can define a data type. So we have different data types. Let's understand. So let's start with something called number. So number is used across for every type of number, from a basic byte till the double. Like it covers whole numbers like a decimals, floating variables, or big numbers, big ints. Everything in JavaScript hold is actually you know uh, under number data type itself. It's kind of a
Yeah.
primitive type we have, right? So similarly, so
Mm-hmm.
now once you define any variable, which means now we are actually fixing up the type. So I can't just say k as something like true, because as soon as I have this fixed, now this is something which actually makes my qualifies my variable with the specific type I have. Specific type is a specific data type I have. So similarly, I have bool or boolean. So now this qualifies as a
True or
true or
yeah.
false type, right? So let me just mention it in a separate, so that so let me take this, or let's have, let me call something called L as boolean, where I can actually give a true and false. And I have something called, most of the times we'll be using any all of these, not one of them. It depends on which we're using. And sometimes we'll be using, so these are the types which we are the primitive types, which are kind of a defined types, and they have their own specific type of data which we can assign, right? So there are a few other types which are kind of a subset types we have, which we can actually use called anyways, these are something which are always there in across different you know um, programming languages like null we normally call, or blank, something, right? So most of the times when we deal with the variables in mainly TypeScript or JavaScript world, if data is not available, right, we either it will be null or undefined, basically. So forget about the blank one. Blank in the sense, if I have a string with no data, this is different. This is not null or undefined. Fine. So in a TypeScript world, even these are kind of a sub types we have. So which means we can also define, if you want to define a variable called undefined itself, yes, you can always define. So let's say I'm going to call u as undefined. So I'll just say undefined. Undefined is nothing but, so I can use this variable for any comparisons, or I can use this variable to assign something which is not initialized and stuff. But end of the day, I can have undefined for undefined type, or I can have for any primitive type. So I can even have a number where initially I'm just said, okay, man, I'm defining a number, but I don't have any value. So similarly, I can just take u as, for instance, like 89. So now it takes a value, because end of the day, even if it is initially undefined, I can actually use the same variable to assign different values as such, but restricts to number. Similarly, we have null. You can actually have a null type, which can be which is again a subtype of this. You can have any type of data type assigned with null, which means the initial value which I'm giving for L is null, but end of the day, L is a type of Boolean. Okay. So similarly, we have, so if you remember this one, the first type we use, right? If you see the intelligence there,
Mhm.
it says let t colon any. So this is
Yeah.
something which we have. I would say this is a very useful type we have, and also this is something which opens up into different concerns also. So we have to use this any type very calculated way whenever we are defining anything in the sense objects or any types. Using this any will take any type of data to hold on a variable, basically. So it's similar to that. So which means, right, you can just say let maybe h of type any. Just define this, and this will take any type. I can have a Boolean value, I can have like number or decimal, anything. So this any is nothing but, even if you don't by default, right, if you don't define anything, that's any. And if you want to qualify your variable with the data type, you can just mention that data type as such, so that it will hold only that specific type of data. So that's how these data type works, like a Boolean. These are the specific data types we have. Undefined and null are the subsets which we can use across any data type, and any is something which can be used to open up the variable for any type of data which we hold. So these are the ones which we'll be using for some of the types, like when we are actually calling any endpoints and you don't know, um, and if you want to actually generate typecast to any data, and you don't know which type you're gonna get unless you actually hold it, right? In those situations, what we'll do, we'll actually return the promises based on any type, but based on the output, once we get it, right, based on the type check, we can decide whether it is certain X type or a Y type or Z types. So in those situations, any is very useful. Okay. So anyways,
Okay.
we're gonna see those examples too when we once we have a services defined in Angular, right? So those
Mhm.
services type of return types, which are actually included with the promises, we'll be using this any type also um, in our services, or sometimes once we see it across Angular.
Sure.
Okay, and so this is mainly the variables and data types declarations how we do. I think this anyways is a straightforward stuff which we have, where a normal types we can define. So in the same way, right, if you're whenever we're actually defining a number, which means in the same way I can define the collection of numbers too, right, which we normally call a list in let's say .NET. And here we normally take it as a array. Okay,
Yeah.
so yeah, we take it as an array, or let's not get into the object, we'll see the object in later time. So here most of the times we have, when when we talk about collection of items, right, the collection of items in JavaScript mainly is an array, simple as that. So
Mhm.
object of objects, and those are completely different terms. So here if you want to talk about some collection, it's array. So for instance, let's say I'm taking some variable arr, excuse me, and let's say I'm going to take some numbers for instance, okay, and array. So this is my number array, and this will allow array where you can have values only of number type. So what I can do, I can have arr as some numbers, for instance some 3, 5 and 8 for instance. So I can't have anything out of array, because here we have defined array as a
Number.
specific type of it. So let's
Hmm.
say for instance if I say any, right, any is something again, I mean, anyways, we don't have to actually get back again, but if you want to define an array where you want to actually take any type of data, irrespective of this, yes, you can define any, and you can have any type of data loaded into it. Okay, so there are two different
Okay.
ways how you define. Either you can have this one. I'm talking specifically about TypeScript. So once you save it and just open up this, right? So end of the day, it will actually take kind of an array itself. If you see here, it just, because JavaScript doesn't actually understand directly called as an array, like, right? So it defines it and just dumps up into it, and it will automatically become an array. If you see. So this is the one which is actually shown as a TypeScript, but it actually takes up. Now here, similarly, we have in TypeScript itself, we have something called um, um, reserved word called array, right? So where you can actually define an array with a token called array, right? And you can actually give an type here. So similarly, for instance, if I give a number, now it's going to take only number. So anyways, you can either use that, or you can directly use a registered keyword called array, which is kind of an internal interface we have in here. Okay, so similarly, there are some situations where um, like if I give any, right, which means I can actually have any type, right? I can have true and stuff. Now, there are some situations where in some of our service calls, for instance, I want to actually get two different type of data. Let's say I want to get a string and a Boolean, right? It can happen that whenever I call any endpoint, it is going to return two different type of data, and I should have a capability to hold only that specific type of data, right? So for instance, if I give any, now it doesn't have any kind of restriction over data, right? So what I'm saying, I just want to hold only a string and for instance number. I want to get only these two, not more than this. So how can I achieve this stuff? I can't use array, because if I use array, which means I'm actually opening up the gate to have any type, because I'm using any, but I want to restrict. So for this reason, we have something called tuple. If you remember, we were talking about uh, the concept called tuples yesterday.
Yes, yes.
I think you read it. I think it will be in first page of a handbook itself, which means you
Yeah,
can,
yeah, I read it.
yeah, while defining your variable itself, array we
You
have.
can actually
Now,
say
then what exactly it is? Let's say, for example, I'm saying response, let me just remove this. Let response of type array, but what type of array? It's a number and a string and a number. So this strictly takes a string and a number. Now I can't actually give any more. For instance, if I give some more values, right, now it says that okay, fine, this is array which is valid, but I can't hold this data because my restriction is to take an array of two values of these two. That's all. That's how it is. Fine. So this is how we normally use. I mean, why I'm actually giving this example? We have this. We will see this scenario, right, where we are gonna return some bunch of different types, but we'll be binding them with a different different components. Okay, based on which component we're calling, we'll just return different types, but we'll be handling based on different components and showing up data based on that. Then we'll see basically.
Okay.
Okay, so now when we are talking about this, we also will get an quick thought of, okay, fine, this is something which is going on. How about an object, right? So when we talk about object, so JavaScript object holds in a flower brackets basically. So I can actually define an object in a very simple way, like let's say I have a let. So there is nothing, no data type called object, for instance, right? It's just like if I say O is equal to so and so data, for instance, I'm just defining something called, let's say, ID as 123, and for instance name as, let's say, Sri. So that's all. I mean, this is a type of object we have. And then if I want to actually access my object, yes, I can do that. You can see here, as soon as I say O dot, it gives, yeah, O contains ID and name. If you remember something called anonymous types, I mean, I'm just comparing
Yes,
with
yes.
Link. So this is kind of this will generate an anonymous object with specific properties and whatever values are assigned, and that will actually give us like an object kind of.
Okay.
Fine. So here you don't have to actually define a type for the object, but for restricting the properties, yes, we can do that. So now
Mhm.
how can actually we restrict the properties? Now if you, so here, right, if you see this object, there is no specific designated structure we have for this, right? We don't have that structure. But if we can actually give a structure to this object, then yes, we can restrict it. We'll see this in a while. So before that, let's, even before we actually get out of this, let's understand one more thing here during data types. See, whenever we discuss about data type, we'll get some other stuff called custom data types, right? When we talk about data types, we also have something called custom data types, and one of the custom data type which we always know in all technologies is enums. Enums are the ones which are custom defined data types, right? So the way we normally say, let, like for instance, something p as number and give something. Similarly, I want to define my own type, saying that, okay, this restricts all my numbers. But how can I restrict a variable taking few values? So in order to do that, we have something called enum. So we do have something called enum, excuse me, where I can define my enum here. For instance, let's say I'm going to take something called names here. So something, some maybe I'll give Tom, some bin, let's say Ken. So a simple enum we created. Now this is my enum, and I can restrict my variable or any variable defined with my enum mentioned. For instance, I can say en with names. Now here we are actually defining the enum variable called en, and say we're saying that, okay, man, en is a variable, but it should take only of type names. And what is names? Names is an enum type.
Tom
Now,
Bean can, yeah.
I'm sorry.
Only we can define of Tom Bean can.
Correct. Now here, if you see, if I assign en with 10, right, it takes 10. Why? Because for enums, as we know that every value of a enum is assigned internally to a number. So if you don't assign anything, it will be like 0, 1, 2, and so on, right? So that's why
Yeah.
if we give any number, it does take. So for instance, if I just say something like true, right? So now if you see, true is something which is not a number, right? So because it is not a number, it just gives saying that okay man, you have defined it as a name type, but you are assigning some other type, so that doesn't work.
Mhm.
So that's why what we do, we normally take names dot, we can have this again. So the
Mhm.
IntelliSense is very good in TypeScript if you're using a proper IDE actually. I can just use this kind of. Now, if you print it, right? Let's say I'm gonna print console.log of en, for instance. So I'm just running node my file. If you see here, it gives me 1. Tom, as I said, it starts with 0, 1, and 2. So my en value is bin, and when I print en, it gives me the value of it. Now here, if I give some value for 10, Tom, I mean it's the same concept which you have for in either in Java or C sharp. Like if I actually mention anything in 10 or like 100 here, for instance, I want to start anything with 100. Now if I try to print that, now if you see, it will give 101 because it's 100. From next on, it will automatically increment the values kind of.
Mhm.
Okay, so this is how we can actually define a custom types we have. And again, so whenever we have any type, right, it will automatically give, we just saw the IntelliSense, right? It gives IntelliSense for anything as such. It because by default it understands what exactly it is. For instance, we have a number, so for number, whatever features or internal functions we can get, it actually gives up everything. So we can convert this number into two string, or we can actually convert into a fixed or whatever. So similarly for string, for instance, like we have something called trim, lowercase, uppercase, and star, and whatnot. This is like kind of very cool. We have it TypeScript basically. Don't have to worry much about how it actually get converted, because it's gonna actually support ES based on the version of TypeScript where we normally use kind of.
Mhm.
So yeah. So now, this is how we normally use variables and types and custom types as we have. Now let's jump into functions. So mainly, if we have understood this, the functions, like everything else, like if you are using function. So as we just had a function called, for instance, let's take a function, maybe some sum. I'll say a comma b. So this is a plain JavaScript function, return a plus b. So as I mentioned, even if you write a simple JavaScript, if just dump it, it will accept. TypeScript will accept anything. So now if I just say console.log of sum of, let's say, 20 comma 30, so this is gonna give me sum, right? So here there is no restriction. If you see here, there is no restriction as such. We are just mentioning up things, and we just gave. And now if you run it, you'll just see the, oh sorry, I gave a is equal to, I'm sorry, a plus b, and let me just run this. It'll give you 50, which is sum of two different numbers.
Mhm.
So let's improvise this function to see different things we have. Now as we have a type restriction in TypeScript, we can restrict these to some types. Let's say I want these to always be a number, for instance, and b also I want to be a number. Okay, so
Okay.
now if I try to give any different value here, it doesn't accept because we are now restricting it. So now anyways, it does take this. And now if I try to give any one variable, for instance, sorry, if I try to give one parameter,
So,
now it is actually, yeah, we were talking about the type restriction here, right? So now I can actually restrict my types here, so where we can actually call it up here. And now I can also restrict the return type of this now. So we have something called the arrow functions, which we normally call. Anyways, no, I can just define a function. Let's say a function with name. The function name is sum, which takes some parameters, which is nothing but my, this is the function. So we normally call these as arrow functions. Basically, you can just write up, and then I can have my, for instance, I can take number as my return type. So if it is not like more, I mean, if you're used to it, you can actually do. Otherwise, you can simply use the functions. Either way is fine. So which takes two numbers and it will make sure that only number is returned, right? So this will actually make the function more type restricted. Okay, what exactly I'm taking and what exactly I'm returning.
Mhm.
Similarly, we can actually have I mean, as we have functions with kind of an, now the parameters are mandatory, right? Now here we're actually mandating the parameters, right? So if you take a plain JavaScript functions, even if I actually don't send a second parameter, it will automatically say undefined and it goes on. But in TypeScript, as it is
Okay.
completely restricted, yes, we also have something called optional parameters, right? So if you feel that okay, so only one of these is mandatory, yes, you can still pass it on. So let's say A is mandatory, only one, at least one of them is mandatory. For instance, yes, I can say that okay, B is not mandatory. Okay, just have a question mark here. So this will automatically take your it'll actually skip taking the second variable if you don't want. So for instance, if I just say here sum of 20, it takes up because this is not a mandatory one. So what I can do here, I can just assign some variable. For instance, if I can check if condition for B, if B, this is a simple JavaScript check we do. So what we are doing, we are just checking if B is, this one check, right, will check multiple things. It checks three different main things: undefined, or null, or blank. So this one check actually checks for all these things. So for instance, if you don't pass B, then let's say for example, I'm assigning B with 100, for instance, right? So which means now we are making this optional, making sure that the functionality works properly. It doesn't break because I can't actually have a number and an undefined, right? So I need to have some value even if someone is not passing. So here, let me run this. So you'll see 120 and n. Oh, this doesn't. We have a number here. We passed A, and then if, oh sorry, if not B. I'm sorry. So if you take B, if B in the sense, okay, if everything is proper, then yes, don't assign anything. And if we say not, which means if something is wrong, which means if it is a null or a undefined or a blank, yes, then I want to assign something and then do a calculation kind of. So now let me save this. Let me
So
speed
if
this up.
B,
Yeah, go ahead.
okay.
Yeah, so this is a conditional check. So this is same as checking like, so if B is equal to undefined, right? So instead of excuse me, or like B is equal to null, or if it is a string type internally, it will also check if B is blank
Mhm.
or any type. So all these things are kind of a one check basically. So it actually includes one. So we don't have to actually have multiple things checked on a single variable we have. We can just check if okay, this is a valid value or not. If not valid value, then take something. That's how it is. Similarly, we were talking about optional parameter. We can also make this optional parameter as a optional but a default. Meaning, so here we just took something called optional, right? Let's say no, I want to make this as an optional, but I don't want to actually have any condition check or anything. Okay, if it is optional, just excuse me. One moment. Let me just drink some water. Excuse me. I'm sorry. I'm just feeling some. So I don't want it to be optional, but yeah, I mean, just take some value even if someone doesn't pass anything. So we don't need this anymore. Let's say I'm commenting this for instance. Now I have a B which is kind of a default. We should not call it as an optional. This is something which is called as default parameter. I mean, it's the same as a other language we have, right? It's a default we have, which means if you don't pass this value, it will get automatically initialized with 500 and it will give me this function doesn't break even if it has like one parameter passed. So similarly, if you run this, you will see uh, the output as 150 with 2030 and then 120 taking the default value you have. So we gave 500, right? Oh, sorry, output is here 520. So that's how the default values actually work. Fine. So I mean, mainly the functions now. So now this can be improved, like multiple. We just gave a quick shot of how the function different type it works, right? We can just say like if the function which doesn't know what it returns, I can just say any, for instance, right? I can give any in the sense, okay, man. I mean, I'm just giving this, but I don't know what type you're gonna return. I'm gonna take anything, for instance. So I can just return something called hey, right? So which means, right, I mean, anyone calls this function, I'm just gonna return something. So this is how it actually allows the function to say, okay, fine, return I don't know what type of value I'm gonna get. I'm just gonna say, okay, fine, this is something which I'm gonna return, kind of. Okay, so that's how we normally have different functions. Anyways, we can actually have multiple. Anyways, excuse me, conditional checks or switch cases, all those things. When once we have services writing, right, we'll actually see more on it. And then anything else in function to see, I think we can take any type of, any number of, or any type of you know parameters we need, basically. Okay, so now again, getting back to the same variables here, if you remember, we were talking about any, right? Any, and we were talking about tuples, where you can actually have multiple type of array, where you can actually restrict it. So similarly, we have one more a cool feature called, for a single variable you can actually allow multiple types, in the sense, not like any is like open, you're actually opening the gate. For instance, if you want to actually have this hash either a boolean type or a number type, you can do that. So that's one more good feature we have. Like, I can say like maybe hj, I want it to be a boolean and also to be a number. I can do that. So these are called as a union types, basically. So where I can just say hj as 90 and hj also as false. So based on I'm sorry, based on the type we are assigning, it will take. But I can't actually have hj as some string. I can't have that, because end of the day, anyways, we gave multiple. But yes, I mean, this is a like kind of a strange feature we have. But yes, we do have feature where you can actually have multiple types restriction for one variable, and it can actually hold that type in it. This we normally called as a union, or union typed variable, where we can actually have multiple things actually assigned to single variable. And now getting back to, for instance, yeah, let's see in the same function, one topic will actually get into mainly the interface, basically. So we were talking about this object, right? For instance, I have this object, um, this object defined, right? So so let me take a simple function. Let me just call it as o1, the same function. This, like, we can actually have understand this much better in function. Let's say um, some, let's say something method one. Let's say here I want a type of object, for instance, right here. So I can directly say yes, in this method I want a type of object. So I'm starting to improve the concept to understand interface here. Okay, so by actually giving up a normal object, so we have a normal object here, which is fine. Now in this object, yes, we gave id and name. We don't have any structure to say, okay, id is mandatory or name is mandatory, or I can't take this, or I can't restrict something and stuff. As of now, it doesn't have. Now First, what I want to do is I want to restrict it to something. So now how can we do that? So for instance, let's say I'm going to take let's say I'm going to take some argument here, g1 for instance, right, of some type. So let's say I'm going to take a type. Let's say I want id of string comma name of string. Now it does it look like an object? Like we're saying that okay fine, r1 can take object where the property should be id, should be a string type, and name should be a string type again. Now, so here I can actually read that console.log of, for instance, arg1 dot cid. I can print id, and similarly console.log of arg1 dot name, right? And let's say I'm going to call this method. So I'll call this method 1 of o1. So where you can see this accepts the object. Why? Because this object does have same actually properties. Run this. So let's say I'm going to run this. You can see it says 1, 2, 3 and 3. So this is an ID and this is a name we have. Now let's improve this a bit. See, as of now we have only 2 variables here, right? Let's say for example I have 10 different variables, 10 different properties in this object. We can't actually keep this extending a lot, correct? Now that's a reason why we have something called skeleton interfaces here, where I can have an interface with operations defined. So where let's say I'm going to define an interface. It's easy. So let's say my object, for instance, I'm going to take or just a like employee, meaningful one, where I'm going to have ID. Let's say this time I'm going to restrict ID with a number and name with a string. Now instead of giving this complete object, what I can do, I can just give employee here, which means I want an argument of type employee. Now here we have a restriction here. Now if you see, if I try to actually assign take this object, it doesn't work. Why? Because this structure restricts id with number, but in this object id is not a number. So let's give number here. Let's say I'm going to give 1, 2, 3. Oh, I'm sorry. So 1, 2, 3 here. Now if you see, yes, this structure is valid, which actually is compatible with my interface here, right? And if you see here, if you run this method again, you'll see the same 1, 2, 3, which is a number, and name is 3. So in this, right, I can actually make some of them optional, some of them. So if you just define in a normal plain way, and if I don't give this name, for instance, right, now if you see, it is restricting my type. Yes, man, you asked me to actually give an employee type of it, but the object which we are passing doesn't seems to be following the required properties it needs. So it is actually mandating. Now, for instance, if I give question mark here, which means, yes, you can follow this employee, but name, if you want, you can provide, otherwise don't give it, kind of. So now, yes, that's what we did. There is an ID, but there is no name. So let's run this. If you see, the ID is 1, 2, 3, but we don't have name, so just give undefined, which means, yes, this is how we actually restrict it, saying, okay, if you want some optional, yeah, we can actually make it optional, and if you want it mandated, yes, just mandate it. So this is a kind of a skeleton which we are creating for an object which actually restricts the type we have to restrict the type of an object which we are actually passing on. So the structure should match, kind of. I can have name to some ABC and it does work. So this is how we can actually create a models now. So now this is something where we're going to create models which are kind of a, I mean the naming convention is same. The model which we use in, for example, other language like C# or Java is like we use a class defining all the properties with getsets, right? Similarly here we're gonna have our models as an interface defined structure with all the properties and restricted types, and we can have some optional properties to define, and the mandated properties also kind of define. Does this make sense?
Yeah,
Yeah,
understood.
so this actually gives up a restriction, yeah, where we can actually use the actual interfaces as the models we're going to use, because when we're actually talking about the services which talks to components, basically which will be shown on any page or any view, we're going to send some model. We will not just throw data directly as a loosely data. We're going to have our own models, and models, components understand models, service understand models, and similarly the binded view also understands the same model we have, kind of. Okay, so I hope this is what we have on high level. We have one more very important thing to learn called in
class.
even in JavaScript we have prototype. Using prototype you can actually define the complete object orientedness across the even with the plain JavaScript. But that's something where you have to write so much of code, and it's like very cumbersome to write. So but TypeScript gives us a very simple class stuff, and also we're going to see access modifiers in class, basically, I mean for stuff. And also we'll see the inheritance and how access modifiers actually work, and how we can actually how the inheritance basically works here, and how we can actually utilize the parent child relations, and sharing up the variable, sharing up the methods, sharing up the operations and stuff. Once we have
We'll see.
understanding on class mainly, and the hierarchy of classes, right, then I think we can directly jump into our main topics of Angular.